Howdy folks. So a while back on my main channel I did a video about power resistors and measuring the output power of an amplifier, and I used this amplifier in that video just for the quick demo. And I was just putting this away, and then I kind of realized I don't think I've ever taken this thing apart and actually given it a good look inside. So I thought I would do that before I put this back in storage, because I don't actively use this. I have so many receivers. I have a couple spares. This one is a JVC RX-515V, and they say it's a digital surround system receiver. And this thing is, the digital part is a little bit misleading. It's got Dolby Digital capabilities in it. It's not really a true surround sound receiver because it only accepts stereo inputs. So when you take a look at the back, it only has RCA stereo inputs, and it uses Dolby's sort of just one of their sound processor chips to split that up and artificially generate the other 3 channels, because this is of course a 5-channel amplifier. It's a pretty decent amplifier by my standards. I mean, it's 80 watts per channel into the 2 primary channels, and I believe the other channels are 25 watts, but I may be wrong on that. It's got a display on the front. It's I believe it's a VFD, I believe, and it's got a remote control. It's it's pretty standard tone controls, a bunch of inputs. It's got a built-in tuner, which is not terribly useful these days. It has a phono input. It has a built-in RAA phono preamp, which is nice, and it's got a fully analog volume control. I really love these, where there's actually a motor on the back of this that will turn this when you use the remote buttons. So it's actually a pot that actually does the volume control. So that's really nice in my opinion. I kind of don't like a lot of things have digital volume controls, and they're really bad because it's either too loud, like one step is either too loud and the other step is too quiet. You can't get the exact volume you want, whereas with a pot you can get exactly the volume you want all the time. So nice to see that. It's got dual speakers, as you'd sort of expect anything of this era to have. This thing, by the way, is from 1993, so that puts it at 23 years old. So it still works great. So I expect to see some pretty decent components in this. And being JVC, which is Japanese, I expect to see some pretty good stuff in here. But let's take a look at the back and just see what kind of input and output jacks this thing has. So taking a look at the back, on the left-hand side, of course, we've got all the inputs. We've got all of the phono jacks. The phono is on the top with its ground over here. We've got the antenna terminals for the AM and FM, the AM loop, and the just the FM 75 ohm. And then we've got some tape stuff. And of course, this is a receiver, so it does have composite video, analog video that passes through it. It's basically just a switch. It doesn't do any video processing, doesn't have any on-screen overlays. It's just basically an analog switch for what goes basically out to your TV and what you want to see. It of course follows the audio, but I mean, nowadays this thing is basically useless. It's an amplifier by today's standards. And of course we've got our speaker terminals. So we've got our main speakers here, and then we've got our surround speakers here, the center and the rear. There is no subwoofer out, so this is a 5-channel amplifier, not a 5.1 channel. And on this side we've just got some switched outlets, and there's all the information if you are interested. There we go, JVC stereo receiver, 270 watts. I believe that's a 7. I think I've just made it worse. There's all this goo on the back of it. I'm not entirely sure where this came from. But yeah, 270 watts, 360 VA, made in Malaysia. Interesting. So it is JVC, but it's not made in Japan. Interesting. So I was wrong. Okay. So I've already taken the screws out of this. So let's take the lid off and see what's inside. So starting with the power input, it comes in here through the mains lead, and it goes on to this first power supply board here, and it's got a little transformer here. This is obviously a standby supply transformer, and you can see it's got a little Obviously, that's a little discrete bridge rectifier there, and a smoothing cap, obviously, for the standby supply. And of course, this thing needs a standby supply because it's got to keep its little processor running so that when you use the remote, it's got the IR blaster. Of course, it can receive that IR code and switch on this relay. And this relay turns on the main power. That's what switches this wonderful transformer on. There is a fuse down here. And this is the main power transformer, and it is a pretty decent size. It doesn't particularly give any specs on it, but I can tell you this thing doesn't, it's not light, that's all I'll say. So they've got little PCBs actually mounted on the transformer, which give you the connections to it, which is kind of nice. I'll note that the fuse on this side is for the standby, and the fuses for the actual, is it for the standby? I should actually check. No, it is. That is for the whole system. The reason why I mention that is because there's actually fuses on this board. There's actually 2 of them on this board. So there's fuses on the input and there's fuses on the output. Of course, the input is to protect the transformer. The output is to protect, the transformer from everything else. And from there, of course, it passes out of the transformer. We've got our much more substantial rectifier here. Again, bridge rectifier, all done with discrete diodes. And one thing that you'll notice is they are mounted off the board. They're standing up like that. And there is actually an intentional reason for doing this. Of course, these diodes, they have a voltage drop across them. Even if they're something like a Schottky diode, they're still going to drop, 0.2, 0.3 volts. And of course, that's going to produce quite a bit of heat. So what they do is they actually use these leads as a heat sink. And if you mount them off the board like this, you will actually you will get heat dissipation in the leads. Whereas if you, of course, mounted them to the board, you clip the leads off, you'd reduce the surface area, and they would get hotter. So this is a really cheap way to get a little bit of extra heat dissipation on a diode. And they've actually done that a little bit on the standby board, and they've used much smaller diodes. So we've also got another set of diodes over here, so I'm not quite sure what they're doing. It appears that there's got to be 2 taps or a center tap or something on this, so I'm not quite sure if there's probably a low voltage supply here and a high voltage supply, because of course all the logic and stuff is not going to run off of this main voltage. Now you might ask, how does the standby supply get to this board? Obviously it's not coming out of the transformer, and the answer is quite interesting. What they've done is they've actually created a little sort of a board arrangement that actually carries that power onto from the mains input board into that other board on the other side. So basically it's just 3 PCBs that they have basically soldered together at right angles with some little jumper wires, and then they've put connectors on the 2 short boards, and they've just plugged it in as sort of a rigid cable, basically, into the 2 boards, which I think is quite novel. And there's three connections on that. So my guess is there's probably ground, a power line, which is the power standby supply, and then one of them is probably a return line for this relay. Of course, because the switching is going to be done on the processor board, and it's going to have to send a signal back to get this relay to turn on. So I think that's why there's probably three wires in that. And they've also used that exact same thing here. They've got, of course, a much wider connector for a lot more signals going from this board over onto this board over here, the main board. So the reason why I think they've done this, and this is just a guess, but obviously this unit has multiple boards. It's got this board, this board. There's the transformer boards, which may or may not come with the transformer. They've got all the boards over there that we'll see in a moment. They could build these boards separately, but what they probably do, and what you can sort of tell they do just by the markings on here, is they panelize these boards. So they build these boards sort of in a copy-paste fashion where it's all duplicated, and then they build it as one big panel, and then they snap it apart at the end. And what's very possible is that when they laid out all the boards in a panel, there was gaps, there was basically extra board left over, because the board at the end of the day should be a square or rectangular. So it's very possible they had strips and stuff left over. So they must have found that it was cheaper to basically turn those strips into connectors than it was to buy a ribbon cable to go across there, for example. And I mean, obviously it must be cheaper, because otherwise why would they do it? There's really no advantage to this over a cable other than cost that I can think of. And normally I would assume this would be more expensive than a cable, so they must have gotten some part of it for free, and that's why I think the board part was probably free. That's my guess as to why they were able to get away with doing this in at least 2 places on this board. Now the actual main sort of logic processor and everything is actually on the front panel, and they've got a bundle of wires going into it here, and they've got a sort of a flat flex going into it here. So I'm going to end up taking this off, and I'm going to do that at the end. For now, we can just look at this part. So this is the volume control board, and you can see it's got a sealed potentiometer with this is the drive motor that I was talking about, that is what is used when you use the remote control. And of course, you can just spin the motor. It's not a big deal. It's definitely gear reduced inside the actual pot. Like this motor and pot is one assembly. You can't buy these separately. So if the motor ever died or the pot ever died, you'd be kind of screwed to get this assembly again. It would be it'd be very, very challenging. And we've obviously just got a little motor driver and all the associated stuff there to drive this, because of course you have to be relatively precise with this to be able to make minute volume control changes. It's not great. I mean, they were never terribly great, but you can actually, if you get fast with the button on the remote, you can actually be very precise with some of these. Most of the amplifiers I have actually have these motorized volume controls, and some are better than others. And this one, as far as I remember, was sort of in the middle of the range. It was mediocre. It wasn't terrible, but it also wasn't great. So this is the main amplifier here. Of course, we've got 2 boards with most of the preamp and signal processing on it. And then we've got the main board, which is sort of an interconnect board, which of course houses the main power transistors. And then we've got this little board here, which handles the rear channels. And of course we've got this little input board here, which is the composite video switching board. So the first board on the from the front it's the right side of the amplifier, from the back it's the left side, would be the basically the tuner. So this is the AM/FM tuner board, and you can see in here we've got looks like it's manufactured by Mitsumi. This is just obviously an integrated RF can, probably for the FM. It would be my guess. And we've just got sort of like a radio and a chip kind of situation going on here. Nothing very interesting to see. We've got crystal kind of flapping in the breeze there. They didn't trim the leads on that, which is kind of weird. Again, they've done that same technique where they leave some extra lead on the resistor. You can see they've formed the leads such that the resistor can't fall any further into the board during manufacture, and it's obviously that resistor gets kind of toasty, and it's not great that that's right next to that cap there, because that of course is going to heat the cap up. So yeah, that's not terribly great. As for the capacitors in this, of course everyone wants to know who makes the caps in things, especially in older gear like this, because really the only thing that's going to fail in this is going to be the capacitors, with just normal age degradation. And they've gone for a variety of manufacturers, probably whoever was cheaper for that class or type or value of capacitor. All these little blue ones are manufactured by Matsushita, or as people more commonly know them, Panasonic. And when this was manufactured, they would have actually been made by Matsushita or probably Panasonic, but they're branded with the M. Now that being said, of course, Matsushita no longer exists. They are now officially known as just Panasonic. The parent company's gone, and they still use that M because it's sort of synonymous. I mean, they make the world's best caps. They've been using that marking for ages. They wouldn't want to get rid of that kind of brand recognition. And there are caps made by other manufacturers. The smaller ones are made by Rubicon. The black ones are Rubicon. And they also make the ones that are, of course, the ones that everyone wants to know, the big ones, which I'll show you in just a moment. But there's nothing really interesting else to see on the tuner card anyway. So the next card would be basically the input board. So this is going to be all of our preamp and any analog processing. So this would be where the Dolby Digital chip is. I expect to see that somewhere on this. There's obviously a switch down there, a chip down there, which I expect to be the analog switch. And I'm not going to bother to take this board out. It's not going to be easy. So I don't really care terribly much about what that is. But we've got a chip here, which is manufactured by JRC, which is Japan Radio Corporation, and it is branded Dolby Digital, Dolby Surround Pro Logic. So that would be your Dolby Digital surround sort of emulation chip. So you give it a stereo signal, and it generates 5 channels out of that through magic, basically. We've got another chip over here by looks like Mitsubishi. I'm not entirely sure what that would be. Another JRC chip there. So there's some transistors. We've got a single inline package back here by, does not say, it doesn't have a manufacturing mark on it, but anyway, there's not terribly much that's exciting on this board. It looks well laid out, and I mean, they've gone super cheap. They've gone for a single-sided board. That's another thing I should note. All the boards in this are single-sided. You'll notice they have jumper links on them here, and the jumper links are basically how they jump over. If they don't use a component to jump over a trace, they use a link to jump over a trace. And these are pretty much the cheapest boards you can build because they only have solder on one side, and they only have traces on one side. So yeah, they've managed to get away with that for all the boards on this that I can see. I'm not entirely sure. The front board may use a double-sided board because I'm assuming there may be surface mount stuff on that. It's possible, but we'll take a look. So on the bottom we've got obviously a little transistor that's got a little tiny heatsink on it. Couple other transistors sort of just flapping there in the breeze. They don't have any support. And we've got these are the speaker AB selector switches, which are just standard switches. Nothing exciting. Although interestingly, the speaker B switch is longer. It has more internal contacts than the speaker A switch. So the way they've wired that up is a little odd, obviously, and they've got just the headphone jack. You can see the back poking out here. So quickly, just for completeness, we'll look at this. This is the analog video board. Just got a little JRC part on there and a couple transistors, and that's about it. There's really nothing sophisticated on that at all. Like I said, it's just going to be a switcher. It's just going to be moving things. It's all solid state, but it's just going to be a switcher. That's all it is. So this, of course, is the main board. And I want to correct what I said. These are not made by Rubicon. These are made by Elna. I don't know why I said Rubicon. These are Elna brand. These are 8,700 microfarad at 63 volts each. So they are pretty decent sized caps for an amplifier that's of this power. And of course, just more general miscellaneous preamp stuff. We've got obviously that would be our speaker protect relay down there, made by Omron, which is a relatively good company for relays. We've got 3 white power resistors here, made by, looks like Mitsubishi, and they're obviously for balancing or something. We have another relay here, which may also be, we may have 2 speaker protect relays in this, which wouldn't surprise me, given the number of channels, of course. This is some coils. This would be your tone control. All the circuitry of the tone control will be right here. So these pots here correspond to bass, treble, and balance is on the other side of this board. There's another pot for that. And then we've got, of course, the stars of the show, of course, the power transistors. Now, this amplifier has 1, 2, 3, 4, 5, 6, 7, 8 power transistors. And of course, they're in pairs. You have a complementary pair. You have an NPN and a PNP, which does the push-pull, because of course this is a Class AB amplifier. Now that would only equal 4 channels, right? If you have a push-pull for each channel, that's 4 channels. But this is not a 4-channel amplifier. This is a 5-channel amplifier. So my guess is that they're doing something interesting with the center channel. And I probably, my best guess is that the center channel probably doesn't have a transistor on this heatsink. So my guess is that there's probably maybe these transistors here are actually what drives the center. So yeah, that's this. Now, of course, people are going to ask me what are the models of transistor they've chosen. So let me try and get in a little bit closer through all this wiring. So it's incredibly difficult to see these transistors, but they are manufactured by, the logo is an R. I'm not entirely sure what that is, but we have an A1633, and on this side we have a C, is that a 4278? So feel free to look those up if you want to know what they're rated for, but this thing's maximally rated for 80 watts per channel out of the 2 main channels. That's at 8 ohms, of course. So that pretty much covers it for the main board here. So let's just take a quick look at what the control electronics look like and the display and everything. And I think that's a pretty comprehensive look at it. So I've managed to get the front panel off of the amplifier. So it was just a bunch of screws all along both sides, and then I had to take the volume knob off, and there was a nut on the holding the shaft of the pot on, so I had to take that off as well. And of course then you can just unhook the 2 cables and it comes right off. So this side is totally not interesting. It's just going to be a bunch of buttons on a board. However, this side is going to be a little bit more interesting, so I've taken the screws off so we can take a look at this. I was wrong in the fact that there is no surface mount at all on this board, so they really have gone for a 100% through-hole design on this amplifier, which of course back in '93 would have been the most cost-effective option. So flipping this over, you can see our beautiful VFD here. This is a vacuum fluorescent display. So this is basically it's a vacuum tube. We've got this little pip here. This is where they vacuum out all the air and then they seal it. And that right there looks to be our getter, which is just a deposit of metal on the glass, which is basically used to, it reacts, it oxidizes with any stray air molecules that are left in the tube after they vacuum it down. And the fact that that isn't white tells me it's just a reflection. It's not actually white, it's kind of silver. The fact that looks good, that means that, of course, there's no leaks, which would be very bad. And of course, it's just all of our input buttons. We've got this little cage here, which actually has our infrared LED in there, which is our infrared receiver, sorry, which is what, of course, receives the IR from the remote. There's also a cap in there. I'm not quite sure why this is in a metal can, but it is. We've just got, of course, our power LED and some other indicators over on this side. Rectifier up here, which obviously. Yeah, that's actually interesting why there's a rectifier on this, but anyway. All of the control is done by this absolutely massive chip underneath the VFD, and it's huge, and unfortunately I can't read it because it's completely underneath the VFD. Now, the way that I would assume that they're doing this, of course, first of all, this VFD requires a high voltage to run, so obviously they're probably using maybe this cap. They're building a boost converter somehow to run this tube. And what I think is going on is probably this chip. Of course, it's going to be custom to drive this display. Of course, the display has, you know, only has certain things on it, so this has to be able to this thing has to be basically designed in either in hardware or programmed with like a mask ROM or something to know how to drive this display. So I think this is probably an ASIC, which is designed for this display to run the amplifier, and it's designed to be hooked directly up. It's got all the built-in circuitry to do, you know, a charge pump to drive this and everything. It's all integrated into one chip. So there's nothing, you know, it's not reusable or anything like that. It would be nice to know just, you know, who even made it, but it's very close to the back of that VFD. I can't get anything in close enough to see that, but obviously it was it went through quality control by 1, 2, 3, maybe 4 people saw this thing. Maybe 5 people saw this thing before it was assembled or as it was being assembled. It's kind of interesting always to see the kind of markings and stuff. But anyway, that's pretty much it for this JVC amplifier. I mean, it's kind of par for the course for a 90s amplifier, early 90s amplifier, but I mean, it's done a really good job. I've only had it for the last, you know, 3 or 4 years. Of course, I didn't buy this thing when it was new, but I mean, it's done really well, and it still works fine, and I'll keep it as long as it's working. So, yeah, I mean, that was a very interesting look at a pretty bog standard amplifier. I mean, it was in 4K. If you didn't realize it, this video was shot in 4K. So if you got a good internet connection and a fancy monitor, you can enable 4K. So anyway, I don't want to waffle on too long. So hopefully that was interesting. Thanks for watching.